Good morning. Good morning, everyone. I have played Cookie Clicker before, Valen. Wait, why is my chat not working? Oh. Oh, there it goes. That's because I wasn't switched over to the source yet. Yeah, no, Valen, I've played Cookie Clicker, but I played Cookie Clicker when it like first came out. No, dude, it's one of the best idle games for sure. It's like one of the OG idle games. Idle games are fun. They're a good waste of time. But if you've played one, you've really played them all. I mean, the real difference between idle games is like how they do the prestige mechanic. That's kind of what sets idle games apart, in my opinion. But Egg Ink, though. I've heard good things about Egg Ink. I've never played it, but I've heard that one's pretty good. How do you guys like the new look? I've started. I used. I'm using Streamlabs OBS instead of just regular OBS. So. Yeah, it is really similar. Just kind of slightly cleaner lines on things. Olivia, did you enjoy the chess stream last night? You tuned in for a little bit. So yeah, I streamed chess for a little bit last night. Lost a bunch of games. Yeah, so I changed. So Lauren, I changed to a different service for chat. I don't know. I'm using a different program to stream. I'm glad you got a kick out of it. No, it was fun. I enjoy chess. I kind of want to do. So the reason I was testing it out is I want to do like a Brighton tournament. So just do like a student run tournament for chess. So just have like an end of the year chess tournament for all my chess club kids and a couple other people. It's just I don't have contact information for chess club, so I'm trying to figure out that stuff out. I can play again. Eli would. I don't know how much Eli's been playing, but he might beat me. Yeah, it'd be fun. So if you're interested in doing chess stuff, you just make an account on chess.com, and then I'll maybe do some stuff after we're done with classes. Nice, Kate. Kate, haven't you already? Didn't you already dye your hair like a week ago? Do you guys like my sweet mug? Oh, Hunter did. Okay. Oh gosh. Oh, a message got deleted. Oh, it's because you put a link. Yeah, so I have a bot too that's gonna auto delete messages and things. Yeah, I like Moobot. I looked at a couple bots. I think Moobot's kind of the best. I messed around with Nightbot for a little bit, but I think Moobot's better, at least for what I want to do. Stoichiometry. Mom, we gotta do stoichiometry. Oh, that's funny. Oh, hello, Cooper. Yeeted or Yod? I like Yeeted. So Moobot is a program that basically runs in the background, and if you kind of break chat rules, it'll just auto delete your message and give you a warning and things like that. So 100% headshot percentage. Did you only fire one shot, Zach? So Ellie, I changed the chat. I'm using Streamlabs. It's a little bit different. So I kind of like it a little better. I think it's more fun. I mean, if you're hacking, you can get 100% headshot percentage. That's easy. Oh, the board game. It's just because people don't believe you. So Zach, if you said like, oh, I had like a 96% headshot, then people would have been like, oh, cool. But when you say 100%, that's like, did you though? Do my best, Leonardo DiCaprio. Sorry, Cooper. Some of your messages are going to get caught by the bot. There you go. Much better. Yeah, it does have a little attitude. I am only slightly doubting you, Zach. You just, I mostly believe you. I have a total of like an hour on CSGO. I am garbage at CSGO. I'm just not an FPS player on like just mouse and keyboard. I have not played Chess X, I don't think. Huh. I look just like normal chess. Oh, interesting. I'll have to check it out. No, I'll have to check it out. Ugh, I love chess though. The game of chess is just a fantastic game. There's been a streamer on Twitch, one of the like top 10 players in the world, a guy by the name of Hikaru Nakamura. He's a US chess player that's started streaming a lot, and he's had like 7,000 or 8,000 people on his Twitch chat in the past couple of days. So, because did XQC give him a shout out? Is that what it was? I think it's just nice to see. It's just nice to see like chess going up. Well, because he had Voyboy on his stream the other day. He like had Yasuo on his stream the other day. He's trying to get like into League, and it's just really interesting to see this like super grandmaster, one of the best chess players in the world, be a part of the Twitch community. And like they've been hosting tournaments on Twitch. Yeah, Hikaru's way cool. I've been like watching his streams in the afternoon because it's just been really interesting. Boom, easy money. He has like 5,000 subs, I think, or he's close to 5,000 subs. So, all right. Oh wait. Oh, did I not get? Is it not alerting? Is my alerts not going? Oh, yeah, there it is. Matthew did it. Okay. Yeah, my alerts aren't showing for the... No. My alerts aren't showing for the valence electron redemptions. I don't know if I can do that in my alert box. I think I was messing with it. Yeah, I can't. That's not added to alert box, but that's okay. All right, let's get started. So if you haven't pulled up your homework yet, right? So if you haven't looked, okay, go modules, right? In modules, we're on the chapter 2, part 2. We have the stoichiometry worksheet submission. All right. 16 questions. So on this one, I put the file submission question first, just to kind of emphasize, hey, this is where you need to put it. And it's also easier to grade. Weaver, I got you. Because then we don't have to scroll down to the bottom to get to to download the file link. So mostly for me, a little bit for you guys. But the file submission question is first. So you want to upload and show your work. You're welcome, Weaver. I got you. But yeah. So then the rest is just kind of this is the worksheet just parsed out into different questions. So we've got, the next 45 minutes or so that we can go through some of these questions. So which ones do you guys want to do? Which ones did we have problems with as you've been working through it? 12. Tyler says 12. We're doing 12 first. Zach also mentions 4. Maybe we'll do 4 first because it's a little bit there. I'll talk about that, Olivia. I'll talk about that. Actually, I can do that in... Yeah. Wait, I'm at 8. Okay, we'll figure this out. Okay, let me make sure that I'm going to do 4 first. Zach, do you mean like 4 on the worksheet or question 4? Because they're numbered different. This is question 5, but it's technically question 4. So I'm assuming you meant 4 on the worksheet. Okay, so let's do this one. It says gold has a density of 19 grams per milliliter. How many moles of gold are in a liter of gold? Okay, so the problem we would set it up, right? We would set it up as how many moles of gold are in 1 liter of gold, right? So that's our setup we start with. How many moles of gold are in a liter of gold? Oh, shoot. Yeah, sorry. Thanks, Trinity. Good catch. This is number 4. So how many moles of gold are in a liter of gold? And then they give you the density in grams per milliliter. I haven't really mentioned this before, but there are some metric prefixes you guys should know, specifically milli and kilo. So when you say milli, milli is like 1/1000th, and kilo is 1,000. And so when we talk about liters, if we want to convert liters to milliliters, we would say that 1 liter is 1,000 milliliters, right? So 1 liter of gold, 1 liter is 1,000 milliliters. And then this is where we can use the density. They told us the density was 19 grams per milliliter. And so since milliliters is up top, I want milliliters on bottom. So 1 milliliter, 19 grams of gold. Okay, so we started with liters. We changed liters into milliliters. That's just a metric conversion. There's always 1,000 milliliters into liters. They gave us the density as grams of gold per liter. And then lastly, how do we change grams into moles? Yeah, we go to the periodic table, right? So we look at the periodic table. Gold on the periodic table is 197 if we round off, so 197.0. So that means there are 197 grams of gold for every 1 mole of gold. And I don't have my calculator on me. Shoot. It's up there. All right, so we do the math. We take 1,000 times 19 divided by 197, and we get 96.4. That's a lot of moles. I did hear about that, Xander. It was a pretty funny news story. So 96 moles. Hannah, what's your question? This is a long question. Are you typing it out? I'm betting. So I got 95.9 because I got the exact numbers. Okay, so great question, right? So the way I have it in Canvas, right, is I have it saying that it's correct. I think I have it set to where if it's like anywhere from 94 to 98 or something like that. So as long as it falls in that range because of rounding, you'll get the correct answer. Yeah, so I have a range, and that's the main reason I have a range is because it depends on when you round the molar masses, and so I always have a range on every problem that's plus or minus 2 or 3 percentage points, or like percent of the value. So that's because I told it to advertise Twitch Prime, Zach. I figured people might not know that they can link their Twitch and their Amazon accounts. Okay. So again, Elliot, we mentioned this. So ml is milliliters. So the problem, let me pull the problem back up. The problem said gold has a density of 19 grams per ml, which is milliliter. And the question asks about a liter, right? And so milliliters and liters, I kind of talked about how they're both metric units. And so that's how we changed milliliters into liters. Right. So that's an important thing to know. I kind of threw that at you guys to see if you would figure it out. I think Moobot should be linking my my YouTube channel too. It should be plugging that pretty soon. Okay. What else did we want to do? What other problem? Let's see. Oh, it already did? Good. Which number? Oh, so Olivia, that's a great question, right? So the idea is that your units are kind of your guide. So you'll notice liters, right? So whatever's here should be on bottom so it cancels. And then whatever's here should be on bottom so it cancels. Whatever's here goes on bottom so it cancels. Okay. So, and then the other thing is to make sure that whatever you have like in a conversion like this, these things need to be equal to each other, right? So 1,000 milliliters and a liter, they're equal. And the reason we put 1,000 milliliters over 1 liter instead of a liter over 1,000 milliliters is so that the units here cancel. Because if we had this the other way, we would end up having liters squared, which doesn't make any sense. And so you want to make sure that whatever unit is here goes on the bottom so it cancels. Yeah, we can go over... the reason why I want to go over number 3, Cooper, real fast before we go to the other ones, is number 3 has scientific notation on it. And so I want to show you guys how to do that on Canvas if you've forgotten. So let's hop back to number 3. And then we'll do maybe 8 or 12. We'll do those. So let's go back over to the canvas. So question 3 asks, how many atoms of iron are in 1/millionth 10 to the negative 6th of a gram, right? So the way we set up the problem, I know I still have it on the other screen, I'm going to jump to this in a second, is how many atoms of iron are in 10 to the negative 6th grams of iron. Can we also do another quick on that worksheet, focus on using the p-table like 1 or 2? This one does. This one pulls in some of that stuff, Zach. So maybe this will help you out here, right? So how many atoms of iron are 10 to the negative 6 grams of iron? Okay. So can we go directly from grams to atoms? No. Yeah, Cooper's right on that. No, we can't go directly from grams to atoms. Okay. What do we have to do as kind of an intermediate between grams and atoms? We got to go through moles. Good, Inya. Good, Cooper. Yeah, so we got to go through moles. Ellie, Xander, everybody, good job. Right? So how do we change grams into moles? How do we change grams and moles? Grayson's got it. Yeah, icy snow, we go very carefully. No, we check the periodic table, okay? So if we look periodic table, we find iron. Iron is here. It's 55.85, so we'll just say 55.8. So we say that there are 55.8 grams in every 1 mole. Again, the reason I put in grams on bottom is because I'm starting with grams, and I want to make sure those cancel. So 55.8 grams of iron in every 1 mole of iron. Okay, so I've got grams, change grams into moles. How do I change moles into atoms? Oh. Either way is fine, Cooper, because it's 55.85, so it's either way. Yeah, Avogadro, nice, Anna. Yeah, and that should be accommodated in the range. So we know that Avogadro's number, so we know in every 1 mole of iron, there is 6.022 times 10 to the 23rd iron atoms. So I'm running out of room to write that. Okay. Now we do have to be very careful when we plug that into our calculator so we don't screw that up. So if I take out my iPhone calculator, right? So 10 to the negative 6th, right? Oh, that's off. Oh. I should have written this as 1 times 10 to the negative 6th. Or when I write it, I should do 10, and then I shouldn't do EE. So because this is, yeah, I should really just do like 10 to the x, something like that. Anyways, regardless, you should have, 5 zeros and then a 1. It should be 1 times 10 to the negative 6th. Either way, 10 to the negative 6, 1 to the negative 6. You just got to be careful using the E notation if you try to do it that way. Anyway, so 1 times 10 to the negative 6th divided by 55.8 times 6.022 EE times 10 to the 23rd. And then equals should give me this number, 1.08 times 10 to the 16th. right? So just round off that third digit, 1.08 times 10 to the 16th. Yeah, on a regular calculator it works. I can change that setting, Lauren. It's just all caps can get a little obnoxious. So that's Avogadro's number, Tyler. So remember, that's the number of atoms in a mole. It's always the number of atoms in a mole. So if we want to relate moles to individual particles or individual atoms, it's always 6.022 times 10 to the 23rd. That's Avogadro's number. Yeah, so I can change that setting, Lauren. All caps can get obnoxious. That's true. Yeah, every other letter being caps is not worse or anything. I think I have it set to be like 80% caps or something. I don't remember. But yeah, I can customize all that stuff. Okay. You guys are gonna get timed out. If you get caught by the bot enough times, it'll kick you out. All caps makes the message better. All right. Now, so what I did want to point out is how do you put this into a canvas? Okay. So on canvas, right? We would write this as 1.08. And then there's a couple ways you can do it. I think the easiest way is to just write E16. And then it automatically changes the number to normal notation for you. Woohoo! Right? So that's all you have to do. I wonder if you can do times 10 to the 16th. Yeah, so it won't let you do it that way. So 1.08 E16. Yep, just one E. So in order to do it in order to do a big number, you just do E16. Now, yeah, actually you can do a big E too. Oh no, you can't. Oh, they've changed that. You used to be able to do a big E. Now you can only do small E's. I need to change my first thing. Yeah, mole is a number just like a dozen. Yep. Yeah, but they do get mad at you when you try to do really small numbers, which is why I changed some of the later problems. Because if you do too small of a number, it'll just change it to 0. So, yeah. Canvas, man, they're changing the programming on us. What are they supposed we use the same assignments each year. That's okay. So I did, you'll notice on, so yeah, big numbers work up to, how big do they go? Can I do 90? Oh, you can. Okay, nope, it won't let you go that high. So it'll let you do 1E99. Whoa, you can write huge numbers. Nope, can't go that high. That's so weird. They let you go all the way up to like 1 times 10 to the 125th, but you can't go less than 1 times 10 to the negative 4th. Yeah, whoever programmed this, I need to call them and yell at them. Yeah. Let's see, here's 0. We're going to go way over here. Just right there is good. Let Mr. Weaver and I talk about being teachers. I don't know who I would even call. Yes, that does count as all caps, Drake. You just got timed out for a minute and a half. So what I did do, yeah, it's definitely not someone at our school. It's someone at the Canvas headquarters. What I did do for these ones that have you do a small number is I went ahead and gave you a hint in that I gave you the exponent. Right? So the question is, how much does one uranium atom weigh in grams? And then I said, Canvas doesn't really like small numbers. Your answer should be something times 10 to the negative 22nd. I just want you to enter the base number. So if it's like 3.05 times 10 to the negative 22nd, just put 3.05. If it's, 9.99 times 10 to the negative 22nd, enter that. So you just have to put your digit here because it doesn't like going down to small exponents, even though it's fine with big exponents. But I still wanted to ask the problems with the small exponents. So for these ones, you don't have to, you just put the number in front of the scientific notation. Yes, it does, Ellie. It does delete your message if you go all caps. Oh, my drink's empty. Okay, so I'll change the settings so it doesn't kick you if you do all caps. I just can't do it right now while we're in the middle of a stream. I'll change it, Ellie. I'll let you guys do all caps again. You guys are so sensitive about your all caps. All right, let's see. Problem 12. A couple people asked about the chloroform one. Oh yeah, thanks, Spencer. I did see your message on chess.com later after the game, but yeah. Okay. Did someone ask about 12? Is that... Oh, I don't want to go back and do 1 or 2. Those are just grams to moles. Those you just use the mass from the periodic table, Zach. All right, so Tyler confirms 12. Let's do 12. So 12 is asking about chloroform. So I need to copy some information down here. So we have the reaction of methane reacting with chlorine gas to make chloroform and hydrochloric acid. So I went ahead and gave you the balanced chemical equation. And then they ask how many grams, so blank grams, how many grams of methane, CH4, are needed to make are equal to 49.2 grams of chloroform, CHCl3. Wait, why did Olivia's get... Oh my gosh, you guys are just like testing the limits of MooBot instead of paying attention. Okay, so let's go back to the question. All right, so number 12. So we have the balanced equation. Yeah, this is chemistry. So I'm going to get to that, Hunter. Right? So we have methane reacting with 3 molecules of chlorine to make chloroform and 3 molecules of hydrochloric acid. So the question is, how many grams of methane are needed to produce 49.2 grams of chloroform? So we talked yesterday, or on Monday, about how you can change moles of one into moles of another using a balanced chemical equation. But you have to have them in moles first. So the first thing we're going to do is we're going to change grams into moles, right? Oh, I should have added ratatouille as a banned word. I didn't. I can do it on the fly. Maybe I'll do that. That'll be funny. Okay, so the first thing we have to do is we have to change grams into moles. So to change grams into moles, we need to look up the weights of these 3 elements from the periodic table. So to do that, we look at periodic table. Okay. So carbon is 12 grams per mole. Hydrogen is 1. Chlorine is 35.5. Right. So 12, 1, 35.5. Okay. So we're going to add these together. Make sure we multiply this one by 3 to get our total mass. Cooper says it's 119.5. And I agree. It is 119.5. So there are 119.5 grams of chloroform in every 1 mole of chloroform. So make sure that when you're doing compounds, you add up all the elements and however many there are in the compound. Okay, now this is where the balanced chemical equation comes into play. In this problem, it's actually not a big deal because if you look at the coefficients of chloroform and methane, they're both 1s. But we still want to have this step in our conversion to say that 1 mole of chloroform comes from 1 mole of methane. Right? Even though it's 1-to-1, and so mathematically it doesn't change the number, it doesn't change the value, it's still important to show that we're changing from chloroform to methane using the coefficients 1 and 1. So while this step mathematically doesn't do anything, we still want to show that those units cancel. And we still want to show the logic there. Last step, because the problem wanted grams of methane, we say that 1 mole of methane is 16 grams. And again, that's just 12 plus 1 times 4. So we multiply, right? We take 49.2 divided by 119.5. 1 and 1 doesn't really matter. Multiply by 16, I get 6.59. Yeah, don't forget to multiply by 16, Cooper. I think you missed that last step. Because you got to change moles back into grams. Yeah, this... Okay. Cool. 6.588. Sure, Cooper. What did I even set it at? Here, I'll just turn off the caps filter. Oh, it was really easy to do. All right, so I disabled the cap spam filter so you can spam caps. Oh, unless it's not updated. Oh, weird. Zach did it too fast, but it should be good now. All right, let's do one more problem, maybe 1 or 2 more. Depends on which ones we want to do. Hannah says 8. Okay. So let's look at 8. Oh, 8's a great problem. I love 8. Okay. So let's talk about 8. So 8 says, a typical bowling ball weighs 16 pounds. Oh, it's because you said ratatouille, Izzy. I added ratatouille as a banned word for like 10 minutes. Oh, shoot, this is 7. Oh, you wanted 8. So this one. Wait, this one? Are you sure, Hannah? This one? The water and calcium carbide? Okay. This is a great problem. This is a great problem. Okay. So we have our equation of CaC2 reacting with 2H2O to make CaOH2. I'm just copying down the equation, C2H2. And then we want to know how many moles, right? So blank moles of acetylene, C2H2. No, that's code for, you'll see. How many moles of C2H2 are equal to 7.28 moles of of water. Okay. Okay. So I think I copied down all the important information, right? So here's our equation. CaC2 plus 2 waters makes CaOH2 and C2H2. So the question is, how many moles of C2H2 are equal to 7.28 moles of water? Now, okay. So how many moles of C2H2 is equal to 7.28 moles of water? So this is interesting. With moles of water, we could technically change moles of water into grams of water, but that wouldn't get us anywhere because we're trying to find moles of acetylene. And so we want to change one formula into another. Now, the only way we know how to change one formula into another is by using our coefficients from our equation. Do you want our work or that we... I want to see the work, Trinity. I want to see what you upload should look like this. If it does not look like this, you will not get points. Yeah, you should show this. Now, it doesn't have to be as spaced out as this, but if I don't see conversions and things like showing the math, you won't get points for the file upload. If you've done it on the actual worksheet, that's fine, as long as I can see it. And you're good. Yeah. As long as I can see the conversions, that's all I'm just checking for, is that you've actually done the conversions in the right format. All right, so back to this problem. This problem is actually easy because the problem's already in moles. So all you have to do is use the coefficients from the equation to say 2 moles of water is equal to 1 mole of C2H2. And that's it. You're done. Oh, I didn't tell it to give a warning, Izzy. Sorry. Apologize. Yeah, 3.64. That's it. You're done. It's just one step. So the reason why this problem, the answer's simple, but solving it can be complicated because you have to recognize, oh wait, I'm already in moles, so I only have to do just one step. In the previous problem, right, we had to change grams into moles, then we used moles to moles, then we changed moles to gram, right? So in this problem though, because the problem's already in moles, and they want you to just solve for moles, you just have to do this converting from one to another using the equation idea. So check what units you have and what units you're solving for so that you can do the conversion. What don't you get, Izzy? Are you talking about the problem? Or are you talking about why you got timed out? Why is it 1/2? Oh, okay, good. So that's from the coefficients, right? There's a 1 here, and there's a 2 there. And so there are 2 moles of water for every 1 mole of acetylene. Okay. Anya, that's a good question. So there is an underlying assumption that we have enough calcium carbide to react, right? So we're assuming that there's enough calcium carbide in this equation. You can think about it. Yes, Tyler, answer your question. You use the bottom number. You can think about it like a recipe, right? So if you're making cookies and your recipe calls for a stick of butter, okay, if you have 4 sticks of butter, you could make the recipe 4 times over. Now, when I say that you could make the recipe 4 times over, I'm assuming that you have enough eggs, sugar, what other ingredients you have, but I don't, in terms of like figuring out how many times I can make the recipe from the butter, I don't worry about the eggs. Does that make sense? Right? Or if my recipe calls for 2 eggs and I have a dozen eggs, I could say, oh, I could make the recipe 6 times. Okay. But yeah, we need the flour and the butter and the sugar and all that other stuff, but we're just assuming we have enough of that other stuff, and we're seeing, okay, how much can I make based on this factor? Okay. Hunter, what kind of cookies are you making without butter in them? Your parents are like health freaks, aren't they? Oh no, applesauce. I knew it. I knew it was coming. Oh no. We still going for 3 number? Yeah, three digits, I think, Tyler, is what your answer, 3.64. Applesauce in brownie mix is actually okay. I don't know about in cookies, though. I feel like it would mess the texture of cookies. I know you can use it in brownies. Like, the brownies is not too bad. You can use applesauce as a sub for oil. But cookies... So Tyler, you would probably want to go one more digit on if the answer was 0.085. You would want to go like 0.0852 if it was that last one. You can use shortening too. My wife doesn't like the flavor of shortening, so I use butter. My personal favorite is like a half mix between butter and shortening. Gives you the best texture, in my opinion, for a cookie. Yeah, 3 numbers, Tyler. Yeah, that's a better way to think about it. Your mom made you burn them? How does your mom make you burn cookies? Did she make you leave them in longer? Shortening is dairy free, and so yeah, I guess it is. I think I don't know if all shortening is pure vegetable oils, but yeah, I think it might be vegan. I have had strawberry rhubarb pie, Cooper. It's good. It's a little too tart for me. I was seeing if anyone else was going to reply to your message. Oops. Pickle pie? That sounds gross. Is it like code for something else, or does it actually have pickles in it? Epic. Hey, Cooper's not dumb. Alright, I'm going to have to look up pickle pie because you guys have me curious now. It's a Utah recipe. I don't know about this. That does not look good. Eggs, half and half. Oh gosh. Sweet pickle chips. So it's a custard pie flavored with pickles. Why in the world would you flavor a custard pie with pickles? Just make a custard pie. Like, you're ruining it with the pickles. Just don't put pickles in there, and then you have a custard pie and it's fine. What? Why? So pickles are actually one of my least favorite foods. I don't really love pickles. Okay. Do you guys want to do? Let's see. How many have we done? We did 4 out of the 15. So we did like a third of the assignment. We'll do one more. Let's do one more. Which one do you guys want to do? "13" says Kate. Oh, 13 is the very last problem. All right, so on 13, you have to not only write the equation, you have to write and balance the equation, but then you have to answer this question about how many grams of hydrogen are needed to produce 12.7 grams of methanol. So I can do it on the same page. So I'm going to write the equation. So it says... Nice trick. It says the fuel methanol, CH3OH, is made by the reaction of carbon monoxide and hydrogen. Okay, so we take carbon monoxide, react it with hydrogen, and we can make methanol. Okay, I'm going to go to my paper here in a second, but I want to get the rest of the information. It says write a balanced chemical equation, and then it says using the reaction above, how many blank grams of hydrogen are needed to make 12.7, are equal to 12.7 grams of methanol. Okay, so let's jump over to the problem. And the timeout for Ratatouille as a banned word ended. So, okay. All right, now I've made some mistakes in this setup. Carbon monoxide plus hydrogen making methanol. What's my first mistake? Yeah, hydrogen's diatomic, so it should be H2. Okay, so make sure we do H2. So don't forget hydrogen gas diatomic. Okay, so when you balance the equation, 1 carbon, 1 carbon, 1 oxygen, 1 oxygen, 4 hydrogens, just 2 hydrogens, and so we need a 2 there. Okay, so we now have a balanced equation, right, with our coefficients of 1, 2, 1. And then we want to know, okay, how many grams of hydrogen are equal to 12.7 grams of methanol? So what should be our first step in the conversion? "32.01 says Tyler. So let's check the molar mass of methanol. So to do that, we need to look at carbon. Pull up my periodic table. Carbon is 12, hydrogen is 1, and oxygen is 16. Right? So if we take 12 plus 1 times 4, we get a total of 32. If we want to go all the way out, we would get 32.01. So, 32. His name is Little Chef. Thank you very much, Izzy. All right, so that's the grams per mole. So then we tack on. All right, so we're trying to change methanol into hydrogen. And so this is where we pull in our coefficients. 1 mole of methanol is 2 moles of hydrogen. Again, because of the coefficients, the coefficient of methanol is a 1, the coefficient of hydrogen is a 2. So for every 2 moles of hydrogen, we make 1 mole of methanol. So to cancel it out, grams, grams, moles, moles, moles of methanol. 1 mole of methanol, 2 moles of hydrogen. And the last step, which I'm going to try to squeeze in, and I probably shouldn't, 1 mole of hydrogen is 2 grams of hydrogen. Because it's H2, so it should be 2 grams. So if I take 12.7 times 2 divided by 32, 12.7 divided by 32 times 2 times 2, I get 1.59. So apparently we need 1.59 grams of hydrogen to make 12.7 grams of methanol. Boy linguini. What's your question, Cooper? Why 2 grams per mole? Because H2 would be 2 grams per mole, because each hydrogen weighs 1. And so a mole of H2 would be 2 grams per mole. Just like oxygen O2 is 32 grams per mole. The mole, but it's a compound. So hydrogen H2 is a compound. Hydrogen gas H2 is a compound. Yeah. Yeah, we say it's a diatomic atom, but it's also an element. Mole, not when we're talking about mass, Cooper. So the reason we did 32 here, right, is because we took 12 plus 3 times 1 plus 16 plus 1, right? That's how we got the 32. We added up all the elements. So in H2, we should add up the elements. There's 2 hydrogens, so we add them up together. Yeah. I don't want to do the last one. Yee. Good, I'm glad, Cooper. No, you're good. We're done. We're wrapping up here in the next minute or two. Oh, they're Drake. Nice, Drake. I could just... Tell Rachel I said hi, Zach. Rachel should have taken AP. Sorry, Drake, I banned your alt account. No multi-boxing my Twitch stream. Yeah, I'm sure she would do okay at it. I think she would get it back. Okay. That's all for today. Make sure to get the worksheet turned in by tomorrow night. If you have other questions, make sure to drop into the Discord either this afternoon or tomorrow afternoon. I'll be available from noon to 2. Otherwise, enjoy the rest of your day. Finish up the worksheet. Keep working on school. We have about a week and a half left in terms of new material and getting stuff done. So keep it up. Keep doing awesome. Bye, guys. Have a great day.